We will now proceed to the cosine theta, and in the third quadrant, cosine is still negative. For the SOHCAHTOA, the cosine is adjacent over hypotenuse. This is our theta. The adjacent side is 3, and the hypotenuse is 3 square root of 5. We can cancel the common. After cancelling the common, so that is equal now to 1 over square root of 5. Rationalize the denominator, square root of 5 over 5. Therefore, cos theta is negative. For the next problem, an angle theta is in standard position with its terminal side in the third quadrant. Find the exact value of cos theta if sin theta is negative 3/5. Are given by a ratio of the sin theta, which is negative 3/5. This is rational because in quadrant 3 the sign is negative. So we will be using the ratio of this sin theta to find the side of this triangle. From the mnemonic SOHCAHTOA, sine is opposite over hypotenuse. Since the sin theta is given, so this numerator is the opposite and the denominator represents our hypotenuse. Since this is our theta, so the opposite of that theta is 3. So the opposite side is here. And the hypotenuse, which is this side, is 5. We need to look for the value of the other leg of the triangle. We will use the Pythagorean theorem in getting that value. C squared equals A squared plus B squared, substituting those values. So the value of our B is 4. Therefore, this side is 4. Now we can solve for the cosine theta. And remember, in quadrant 3, the cosine is negative. Cosine is ka, adjacent over hypotenuse. So the adjacent side of this theta is 4. So we have that. And for the hypotenuse is 5. Since theta is in quadrant 3, the cosine of the theta is negative 4/5. This example is not a unit circle. To dig deeper about the unit circle, we need to discuss now lesson 3, which is about the circular function. We will proceed now to the reference angle. From the definition, let theta be a non-quadrantal angle in standard position. The reference angle of theta is the positive acute angle theta that lies between the terminal side and the x-axis. So always refer to the x-axis in finding your reference angle. So I have here the 4 diagrams of our angle, and I will show to you how to get the reference angle. In diagram number 1, that is in quadrant 1, so just refer to the x-axis for your reference angle to create a triangle. Once you have the triangle using the x-axis, whatever is the angle is your reference angle. In quadrant 2, again refer to the x. So the closer x is here. So create a triangle. So the reference angle here is this one. In the third given, use x-axis. That is our triangle, and the reference angle is this. In the illustration number 4, use the positive x. So this will be your triangle, and the reference angle is this. So the reference angle is the acute angle opposite to the line drawn from the terminal side of the angle to the x-axis. In a circular function, the most common reference angle here are the following angles: 30 degrees, 45 degrees, and 60 degrees. Before we will solve the problem given in this lesson, I will give you something for you to learn so that you can easily get the sine and the cosine of these angles. Make sure that you are a master of using your hand by getting the sine and the cosine of these angles. Inside the hand is a formula, square root of x over 2. That x, we will just count later the fingers left after folding the required degree. For our sine, we will count the fingers from the left until the folded finger, and for the cosine from the right until the folded finger. And that is the value of our x. For the sine 30, this finger is the 30 degree. So we will fold that finger. And for the sine 30, that is from the left until the folded finger. How many finger do we have from the left until the folded finger? We have only this one. We have only one. Therefore, our x is 1. So, sine 30 is 1/2. How about for cosine? Cosine 30. Just fold your finger for the 30. Cosine is from the right. How many fingers do we have until the folded finger? We have 3, this one. So, your x is 3. Just copy the 2. So, the cosine 30 is square root of 3 over 2. Let us proceed now to sine 45 degrees. The 45 is the middle finger, fold the middle finger. The sine is from the left. How many fingers do we have? 2. So, just copy square root of 2 over 2. And for the cosine is from the right. How many fingers? So, we have this one, 2. So, the cosine 45 is also square root of 2 over 2. Next, for the sine 60 degrees. So, we will fold the finger for 60. Like that. Sine is from the left. How many fingers do we have until the folded one? We have 3. So, this is square root of 3 over 2. And for the cosine of 60. Cosine of 60 is like that. From the right, we have only one, this one. So, this is square root of 1 over 2. Simplify, this is 1/2. I think we are now ready for the problem solving. Find the basic trigonometric ratios for the obtuse angle 210. For your guidance, try to plot the 210 angles in standard position, and the graph of that angle is found on the right. That angle is in quadrant 3. Remember the expression as sin tan ko. Quadrant 3, syllable 3 is tan. Quadrant 3 is, the tangent is the only positive in quadrant 3. After that, get the reference angle of that 210. So that is 210 minus 180 degrees. And our reference angle is 30 degrees. Take note also that sine theta is equal to the y and the cos theta is equal to x. And lastly, our radius here is always equal to 1. Why? Because this is a unit circle. And the radius is our hypotenuse of the triangle. In this problem, we need to get the basic trigonometric ratios of this angle. In the module, we are only given by 3 ratios. But in this video, I will show to you how to get the 6 ratios. We will now get the coordinate of the terminal side of the angle. And this angle is in quadrant 3. So we will be using the cos theta for our x and for the sine theta for our y. And since the reference angle is 30 degree, we will be using our hand in identifying the cos 30 degree and the sine 30 degree. Another thing that you need to put in mind is that we are in quadrant 3. So only the tan and its inverse, which is the cotangent, are the positive ratios in this problem. Let's start with the cos theta. So what is cos 30? Why we have negative sign? Because we are in the third quadrant. In the third quadrant, the cosine is negative. And for our sine 30 degrees, the sine 210 degrees is also the value of our y. And the value of our y is negative 1/2. The cosine 210 degree is to solve for our tangent. Our y is negative 1/2 and our x is negative square root of 3 over 2. We will now simplify this. Simply interchange the numerator and the denominator of our denominator. So the negative square root of 3 over 2 becomes negative 2 over square root of 3. Negative times negative is positive. We can cancel the 2. Therefore, the answer is 1 over square root of 3. We need again to rationalize the denominator. Therefore, tangent of 210 degrees is square root of 3 over 3. And this is positive because in quadrant 3, tangent and its inverse are positive. For the cosecant 210 degrees, remember that cosecant is the inverse of our sine. So just get the inverse of the sine. How to get the inverse? Get the reciprocal. Since that is negative 1/2, just interchange the 2 and the 1, but you should retain the negative sign. So the answer for the cosecant 210 degrees is negative 2. For the secant 210 degrees, this is the inverse of our cosine 210. Just also get the reciprocal and retain the negative. So that is the reciprocal of our cos 210. Since the denominator has radical expression, we need to rationalize. So for our secant 210 degrees, that is equal to negative 2 square root of 3 over 3. And lastly, for the cotangent 210 degrees, this is the reciprocal of your tangent 210. So just get the reciprocal. You need to rationalize. Cotangent 210 degrees is square root of 3. And this is also positive because in quadrant 3, again, the tangent and its inverse are the only positive in quadrant 3. So these are the basic trigonometric ratios of the obtuse angle 210 degrees. I will give you one example about the quadrantal angle. In quadrantal angle, we don't have reference angles. So this time, the given angle is pi over 2. This is in radian. So we will convert the pi over 2 into degree. And this is equal to 90 degrees. And in our unit circle, that is the highest point of our unit circle. So the coordinate is 0, 1. Therefore, the x is 0 and the y is 1. So we can now supply the following ratios. For the sine pi over 2, the sine is equal to our y. And our y is 1. For the cosine pi over 2, that is equal to our x. And the given, the x is 0. For the tangent, how to get the tangent? That is y over x. So y over x, our y is 1 and our x is 0. What can you say about this division of number? Since the denominator is 0, therefore this is undefined. And for our inverses, the cosecant pi over 2 is the inverse of the sine. The denominator here is 1. Therefore, in getting the reciprocal, 1 over 1 is still the same 1 over 1. So the cosecant pi over 2 is 1. For the secant pi over 2, remember that 0 here has the denominator of 1. So, if you will get the reciprocal of 0 over 1, that becomes 1 over 0. And since the denominator is 0, therefore the secant of this angle is undefined. And lastly, the cotangent of pi over 2. This is 1 over 0. So we will get the reciprocal. That becomes 0 over 1. 0 over 1 is not anymore undefined, but this is equal to 0. So these are the equivalent trigonometric ratios of pi over 2 rad. For this problem, use the reference angle and appropriate sign to find the exact value of cos negative 7 pi over 6. So how to get the exact value of cos negative 7 pi over 6? We need to convert this radian measure to degree. So what is negative 7 pi over 6? Since the degree is negative, so the rotation is clockwise. So get the negative 210 degrees. So that angle is located now in quadrant 2. So this is in quadrant 2. In the asintan ko, what is the second syllable? Second syllable is the sin or the sign. The sign is the positive of this quadrant. We will now get the reference angle. Our reference angle 210 minus 180 is 30 degrees. In this problem, we are only asked for the exact value of the cosine of negative 7 pi over 6. And since this is in quadrant 2, the cosine in quadrant 2 is also negative. And by using the reference angle, this is equal to the negative of the reference angle is 30 degrees. That is equal to the negative of the cos 30 degrees. So what is cos 30 degrees? Square root of 3 over 2. And since this is negative, therefore, the exact value in this problem is negative square root of 3 over 2.